the woman who discovered the key to measuring cosmic distances. She wasn't allowed to operate telescopes. She wasn't paid fairly. And despite suffering from chronic illness and near-deafness, she made one of the greatest contributions to astronomy. Henrietta Swan Leavitt was one of the Harvard computers, a group of women hired in the late 19th and early 20th century to analyze photographic plates and catalogue stars. It was detailed, painstaking work, but for women in astronomy, it was one of the few opportunities available. They were paid less than a factory worker, barred from using Harvard's telescopes, and rarely credited as leading researchers. But Leavitt's mind saw more than just numbers. While studying Cepheid variable stars in the Magellanic Clouds, she made a groundbreaking discovery. The brighter a Cepheid, the longer its cycle of brightness changes. This was a turning point in astronomy. Before her discovery, the best way to measure cosmic distances, stellar parallax, only worked up to a few hundred light-years. But Leavitt had found a new tool that could measure millions of light-years. Here's how. From the brightness cycle of a Cepheid, she could determine its true luminosity, how bright it actually was. By comparing this with the apparent brightness seen from Earth, she could calculate its distance. All she needed was one Cepheid with a known distance to calibrate the method. Once that was done, any Cepheid, no matter how far away, could serve as a cosmic yardstick. Her work became the foundation for Edwin Hubble, who used it to prove that the universe extends far beyond the Milky Way. Without Leavitt's discovery, we might never have known the true scale of the cosmos. Though she didn't receive worldwide fame, her contributions were respected in her time. She was even nominated for a Nobel Prize in 1925, but the nomination came too late. She had already passed away. Leavitt didn't just shatter the barriers of how far we could measure distances in space. She helped pave the way for generations of women in science. Until today, her work remains fundamental to how we measure the universe.